Hi friends, very warm welcome to my channel. Let us learn something new with SUBBU. And today I am going to discuss one of the very interesting topics in the field of meteorology, that is tropical cyclones. So let me please introduce the most disastrous tropical cyclones to all of you. Welcome to my channel. Please subscribe to my channel if you haven't subscribed yet. Now, when I say the word tropical cyclone, what we all know is it is one of the very devastating natural hazards. You can see different images where the tropical cyclones has created lot of hazards and it has created lot of manpower loss as well as the financial loss. But one query comes to my mind all the times. This much devastating and still it is natural? Isn't it surprising? Because I always believe that all the devastating things whatever happening in the world probably is man-made, but this is not so. This is natural. So I wanted to think and understand why is the nature so much cruel on us. Let us think about this in my perspective. Now, why are the naturally developed tropical cyclones so disastrous? I would like to explain a word natural imbalance to you. The imbalance means when certain things are not distributed properly or there is some partiality, we say that it is not impartial. So naturally there are some things which are not balanced. I call it natural imbalance. What are they? Let us try to understand in my perspective here. Point number 1, we have 7 continents, 5 oceans, we all are taught in our primary school. But when I compare the proportion of the land and the water, 70%, almost 71% of the earth's surface is covered with water and 29% is covered with ocean. That means you don't have exactly 50-50 ratio. Certain things are dominating and that is the water. Second important point is, if I take water and if I take the land, both do not have equal specific heat. That means water can absorb more heat, but land cannot. So as the incoming solar radiation falls on this Earth's surface, water takes more time to become warm, but land becomes warmer faster. So there is definitely one imbalance because of improper proportionment between the water and the land. And also added to that, the specific heat also are different between the land and the water. This alone was not sufficient. In addition to that, what actually happens is our earth is inclined to 23.5 degrees. We all know that. Because of that, what happens is the solar radiation falls overhead over the equatorial region, what you can see here. Whereas on the polar regions, the solar radiation falls on the inclined way. Therefore, the equatorial region always have the surplus of heat, whereas the polar regions have the deficit of heat. So this imbalance is gradually maintained by the release of this energy from the equatorial belt to the polar regions, and that is how the entire atmosphere drives the circulation. But these two facts which I mentioned here is the prime responsible factor which leads to the natural hazards, which I am going to describe later. So you have seen that natural imbalance do exist. In this one, if I take the 6-month cycle, which I call the winter solstice, the incoming solar radiation will be reaching maximum on the southern hemisphere, you can see here. And in the northern hemisphere, this is our winter season. But after 6 months, the same incoming solar radiation becomes overhead on the northern hemisphere, and that becomes our summer season. So that means earth, which is covered with water and land, first of all, there is an imbalance. Water is more, land is less. Second point, the specific heat of water is more, specific heat of land is less. Therefore, water takes more time to warm up and land becomes hotter faster than that. In addition to that, because of the inclination of the earth and also the complete revolving of the earth over the sun, in 6 months this imbalance keep on changing. So what actually it leads to? Now let us look into these aspects. What is the behavior of this warm and cold air? As I mentioned, if there is warmth which is being received from the solar radiation, this cool air will have more molecules. What does it mean? If there are more molecules, that will be having more weight. And if that is having more weight, means that will be having more pressure. Just opposite to that, when it is a warm air will have less molecules. Less molecules means less weight, and less weight means less pressure. So if I depict these things in the atmospheric points, the cool air always tends to descend and warm air always tend to rise up. So the warm air will give rise to low pressure and cold air will give rise to high pressure. This is the take home message right now from this slide. Now if we go and try to translate the previous discussed things, how this wind circulation amidst the high and low pressure systems behaves. In this picture, what I am showing here is high pressure exists here, low pressure exists here, and as per the pressure gradient formula, the wind always tends to move from high pressure to low pressure. Therefore, the high pressure region always winds will be diverging from here, whereas in the case of low pressure, the winds will be converging. And also I mentioned that hot air will rise, cool air will sink. So that is how this gives rise to a kind of circulation which I am showing in this particular picture. But this high and low pressure gradients, that is not the only factor for driving a wind circulation. In addition to that, because our earth is continuously revolving over its own axis with a time period of 24 hours, a fictitious force acts, and that is called the Coriolis force, which tends to move the direction of any moving thing in the northern hemisphere towards right and in the southern hemisphere towards left. This is the equation which derives the Coriolis force. Now, what happens when a low pressure system forms over an ocean? You can see here, if it is in the northern hemisphere, as I mentioned, the low pressure we should have the convergence. Because of this convergence added to the Coriolis force, this becomes a anti-clockwise, or I can say counterclockwise circulation. Whereas in the case of southern hemisphere, it becomes a clockwise circulation. This is resulting because of the Coriolis force. And eventually, what you are seeing here is a typical look of the low pressure, which we call a tropical cyclone. In the northern hemisphere, it looks like counterclockwise, and in the southern hemisphere, it looks like clockwise. But don't forget, both these systems, whether it is the northern hemisphere or southern hemisphere, they are low pressure systems. So we can define a cyclone as a large scale air mass that rotates around a strong center of low atmospheric pressure. This is what the cyclone actually is. Now, as I mentioned, the tropical cyclone is a low pressure system over a warm ocean. The question comes is, low pressure means how much low it should be. What you are seeing here, at the center of this particular cyclone, you can see a very cloudless spot, which we also call eye of the storm, because it looks like eye. So we always say the low pressure sits over the eye, and surrounding region we have high pressure region. So now the point is, when I am saying low pressure and high pressure, unless I quantify how much low, we cannot define a tropical cyclone. So mathematically, if I put the numbers, the atmospheric pressure over the eye of a tropical cyclone can be as low as approximately 0.5% to 50% of the surrounding air. Let us do little bit mathematics. Mean sea level pressure, we all know it is about 1013 hectopascal. If I calculate 0.5 percentage, it will come out as 5 hectopascal. And if I calculate 15 percentage, it will become almost 151 hectopascal. That means the eye of the storm, the pressure over the eye of the storm should be as low as probably 5 and can be as much as 151 hectopascal. That also leads to the exact definition of the tropical cyclones, which we say as soon as the central pressure, that is the central pressure over eye of the storm, drops by more than 6.1 hectopascal, the low pressure system is named a tropical cyclone. Yeah, let me also make it clear, when I say that 6.1 hectopascal, terms and conditions apply. There are some other meteorological factors also which should fulfill the criteria, which I will be describing in coming slides. But for a layman, they can always understand that a low pressure system where the central pressure has dropped by about 6.1 hectopascal, we can call it as a tropical cyclone. Now, depending on the location of the cyclone, we can divide them into two categories. One is the tropical region, typically from 30 degree north to 30 degrees south, which receives surplus of heat, which I was mentioning, is called the tropical region, whereas 30 degree to 60 degree we always call extratropical or the temperate regions. 60 to 90 degree is called the polar regions. By default, 60 to 90 degree is very cool, so this region is not prone for the cyclones. So eventually cyclones form either on the tropical region or probably in the extratropical. If it is between 30 degree north to 30 degree south, we call them tropical cyclones, and for 30 degree to 60 degree, we call them temperate cyclones. That is just because based on the location where the cyclones are formed. Now, a cyclone has different stages. As I initially mentioned that as soon as the pressure of eye of the cyclone drops by about 6 hectopascal, we call it as a tropical cyclone. Now, if I follow the Indian Meteorological Department classification, which is also accepted worldwide, the pressure drops by few hectopascal, not 1 or 2. We just call it as a low pressure region, L. And the wind speed will be less than 9 meters per second. But gradually as the pressure drops more, it goes to the stage of depression. Once it crosses 4.5 hectopascal, we call it deep depression, then the cyclonic storm, then severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storm, and super cyclonic storm. As I am moving from downward, only what is changing is the pressure drop is gradually increasing, and it also leads to the intensity of the devastation that can take place. The stronger a cyclone is, the more dangerous it is. Now, if I take worldwide different names of tropical cyclones, I like this particular saying by William Shakespeare. He said, what is a name? What is there in a name? That which we call a rose by any other name would also smell as sweet as a rose smells. But important point is, name reminds that it is easy for us to capture certain things. So, worldwide, if I take in the different parts of ocean, in the Indian Ocean we call them as the tropical cyclones, but once you go to the Atlantic Ocean and the Pacific, they call hurricanes. In Pacific Ocean, in this near to Japan side, they call it the typhoons. In Australia, they call Willy Willy. But whatsoever, whether it is tropical cyclone, hurricanes, typhoons, and Willy Willy, all are one and the same. They are equally devastating and they are equally dangerous. But they have different names. So don't get confused that whether a hurricane is different from a cyclone. No, it is not. Just because it is formed in a different ocean, they call it with different names. In our Indian region, we call them as tropical cyclones. Now, few important points about tropical cyclone. Let me initially tell about the qualitative characteristics. Qualitatively, a tropical cyclone is composed of a system of thunderstorms because this low pressure will lead to lot of rainfall. Therefore, close to the eyewall region, it will have system of thunderstorms. Second point, any large system of winds that circulates about the center of low atmospheric pressure, as we have seen in the previous slides, that is a tropical cyclone. In a tropical cyclone, the wind rotates inwards and its direction is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Added to that, few more points we should know about a tropical cyclone, that is quantitative. The eye, which I was showing in the previous slides, typically it has a diameter of about 20 to 30 kilometers. You can consider probably a kind of a district. But in some cyclones, it can be as large as 40 to 50 kilometers also. Now, the average diameter of the entire cyclone, it is typically 150 to 250 kilometers. But few cyclones which forms over the Bay of Bengal and the Arabian Sea, we have seen as big as about 1000 kilometers. That is really large, but that depends and also depends on many other factors. One more point, a cyclone cannot be stationary, it moves. So as the cyclone moves, it has to eventually meet a land so that all its energy it dissipates in the terms of rainfall. So that is what we call the movement of a tropical cyclone, or I can say the movement of the eye of the tropical cyclone. It generally moves approximately 300 to 500 kilometers per day. So you can consider that if you are driving a car or something, you may probably be driving with 60 kilometers per hour. But cyclone moves very slowly. It goes 3 to 500 kilometers per day. Now, let us also look into the global distribution of tropical cyclones. The very first point which all of us should know is all over world, approximately 90 to 96 cyclones are reported annually. And if I take the percentage distribution, the maximum occurs in the Pacific Ocean, about 31%, then about 19% close to Australia, 19% close to North America, and the Atlantic Ocean also gives about 16%, whereas the Southern Indian Ocean accounts for about 11%. But the most important for us, the Bay of Bengal and the Arabian Sea, which constitutes the Northern Indian Ocean, that comprises about 4% to 7% of annual tropical cyclones. Now, if I take the climatological perspective of the tropical cyclones from 1891 to 2019, that is about 120 years of data, you can see about 26 to 29 cyclones were formed here. That is the area of cyclogenesis. But first point which is very clear is the Bay of Bengal has more number of cyclones compared to the Arabian Sea. That is very clear picture, that is very eminent from this particular plot. So if I talk about the location, yes, the Bay of Bengal has more cyclones than the Arabian Sea. Second point, are these tropical cyclones period specific also, whether it is any convenient or favorable period is there? To answer to that is, if I take all the cyclone statistics from January to December for the Northern Indian Ocean, you can see approximately 45 cyclones were formed in the October-November, whereas about 30 to 40 cyclones were formed over the Northern Indian Ocean between 1990 to 2020. To make it convenient, we need to divide these months into seasons. We call the January and February as the winter months, March, April and May as the pre-monsoon, June, July, August, September when we get the heavy rainfall is called the southwest monsoon, and the October, November, December is called the post-monsoon season. That is pertinent for the Indian climatic conditions. Now if I divide this data for a longer period and divide them into the months, you can see how many depressions were formed and how many actually turned into cyclones. One important point comes out is pre-monsoon season and the post-monsoon season is more favorable for cyclones, whereas the winter monsoon or the winter months is the least favorable for the cyclones. So immediately an audience will ask why the Bay of Bengal has more number of tropical cyclones than Arabian Sea, and why the post-monsoon season has more number of tropical cyclones. My dear friends, that definitely require a little bit more attention, and what I am going to do is I will make a separate video and cover these aspects in a detail in a separate video. Otherwise the same video becomes lengthier, you all will be bored. So this aspect I will take up in a separate video. Now if I take the seasonal dependence of the Bay of Bengal and Arabian Sea cyclone, which will be the part of next video. Now the question comes is a low pressure is seen, but not all the low pressures will become a cyclone. So there are some conditions which are required for the formation of a cyclone, which we call the cyclogenesis. Point number 1, a disturbance should exist in the ocean. If a disturbance already exists, that will definitely help in formation of a cyclone. Second thing, cyclones cannot form over the cold oceans. So warmer SSTs will help, that is the sea surface temperature. And climatologically we say about 26.5 degrees Celsius cyclones can form. The Coriolis force or Coriolis effect, which is least over the equator, we do not see any cyclones. So adequate amount of Coriolis force is also required, and most of the cyclones are seen to form between 5 degree to 20 degree, and there are no cyclones from -5 to +5, which is the equatorial region. And also we know if tropospheric relative humidity is high, that also helps in the formation of a cyclone. Degree of convective instability, which I can say that if there is rapid cooling of air with height, that also will help in formation of tropical cyclones. And the vertical wind shear should be low. If the low of wind shear is there, that is the wind speed at 200 hectopascal and 850 hectopascal difference, if there is low wind difference, then the formation of cyclone will be possible. But if there are large wind shears, they will not allow to form a tropical cyclones. Now, another question comes is, who gives the formal predictions of tropical cyclones? There are 6 regional specialized meteorological centers worldwide who are authorized to disseminate the formal forecasts of tropical cyclones. That is in the New Delhi, Reunion, Tokyo, Miami, Honolulu, and Adi. They give the tropical cyclone predictions, and they also interact with each other for dissemination of data. Now, before I conclude, one of the very interesting and curious questions comes for all the youngsters as well as the common man is, who gives the names of these tropical cyclones? Let me say first of all, why do we need to give the names? If you give the names, we can identify individual cyclones. It is something like, you know my name, I know your name, different friends have different names. So it becomes easy for us to identify, and we can make them aware also very easily, and we can remember tropical cyclones also very easily, and wider audience can be covered. But the names of tropical cyclones conventionally were given in different manners, but now it is systematic, and it is given by, we say, ESCAP, that is Economic and Social Commission for Asia and the Pacific of the World Meteorological Organizations. Now here I am showing you some of the names which happened in the past. Because the Indian Ocean is covered with the different countries, these many countries, Bangladesh, India, Maldives, Myanmar, Oman, Pakistan, Sri Lanka, Thailand, they used to give the names based on their own way, and gradually follow in this way, and once all the names are over, we will be going to the next list. So each country gets one name, next will be next, like that. And already the future cyclones names are already given, and you may be aware the recent cyclone Gulab which had occurred, that was given by Pakistan. Before to that, Nisarga, Gati, Nivar, Burevi, Tautake, Yas, they were the cyclones which took place. The names given by India for the future cyclones are Gati, Tej, Murasu, Ag, Vyom, Jar, Prabhav, Neer, and so on. These names should not be religiously hurting. Certain protocols are taken into account, and then these names are given. So dear friends, this was something about the tropical cyclones. I hope you all might have enjoyed my talk, and also you might have learned something new. As you say, I also believe I also learned by discussing some things with you. Definitely you may have some queries. Please drop your questions on the comment box and I will definitely try to attend to all of your points and respond back to you. Thank you very much. Please do subscribe to my channel and like and share this video. Thank you once again. Bye bye.